Right, this video is going to be a bit of a shorter video. I'm just going to go through some of the basic health checks that you can go through when you first log into a box. If you want to find out a little bit more about it, it's just some commands that you can run, that you can places you can look up useful information where about the hardware and things that are currently running on it. So for this we'll jump back into our VM and we'll just jump down to a box, whether it's SSH or whether you've got a command line up on a system or you've got a graphical display. The first thing you want to do is jump into root, so you've got access to there's some stuff you can get if you're not root, but usually it's if you're a system administrator, you want to jump into elevated privileges so you can see everything without being oops, not that one. If you're not being sudo dash I, there we go, that's why. Alright, so some of the things you want to jump on, if you're on there the first time, the first thing you usually want to have a look at is things like CPU, RAM and disk space, and do a bit of analysis on that. So the first thing I normally run when I'm jumping into a box, particularly if I suspect it's having issues, is run the Uptime command. So you can see this host here has been up for 38 minutes. 38 minutes ago I rebooted it and it's been powered on since then. The important thing here to look for is this load average. So this load average is based on the amount of load required to basically completely fill one CPU. So if this was 1 and I had one CPU in the box, that means that the box is running at 100% CPU. If this is 1 and I have 2 CPUs in the box, then it's running at 50%. So the next thing to work out then, once you've got the load average, if it's anything, if it's above the number of CPUs in the box, then you're running into problems and you've got to sort of do a bit of an investigation as to why. Maybe see about throwing some more compute at this particular host or splitting out the services into multiple hosts. The next thing to look at, if you're interested in CPU usage, is the top command. Top is one of the most iconic Linux sort of system resource commands. You can see here, you probably recognize this, you may have seen it before. It's often when they have random nerdy computer stuff in TV shows, they'll just run top in the background, usually with some pretty colors. So you start seeing this once you're familiar with it. You'll see it everywhere. You can see here once again we've got the load average at the top here, but this one actually breaks down. You see what applications are running, what's taking up most of the CPU, and you've got in this line here talking about how currently 6.3% of CPU time is taken up with user space applications. This is programs that I'm running. Then you've got 1.3 is with the system and running operating system. You've got this 95.8% is currently idle. This wait time isn't used at the moment, but that's another thing to look out for. Wait time is where the CPU is hung up waiting for I/O, so disk or network usually. If that's getting pretty high, then you've got to work out why, what's chewing into disk usage, or what's it waiting for on the network. Those are the key things there for a CPU. You can also see memory and swap in here. I talked briefly about swap being used when the RAM runs out. You can see this one here has the roughly 2 gig that there is available in the box. Currently running at only 86 meg free. That's pretty low, but it's not a problem because you can see this amount is in buffers and cache. The system will actually start clearing this out before it starts chewing into swap. So that means between the two of them you've got a bit more, closer to 800 meg free. It's not too bad. If you press the 1 key when you're in here, it'll actually split out the CPU load per CPU. So you can this is also a quick and easy way to see how many CPUs there are in the box. Unless there's, sometimes you'll do that and you'll find that there's over 30 and you go, okay, right, that's not the most effective way to find that out. To get a bit more detailed information, you can actually ask the running operating system about what it knows about its CPUs. So to do that, usually cat proc CPU info. And you can see in here there are two processes that are listed. One process here, one process here, one here, and you can tell I'm running an Intel Core i7. This is actually being passed through from the, because this is a virtual machine, it's being passed through from the base OS. So that's the same CPU that I'm running in the physical box that's underlying it. It's just being passed 2 cores for the purpose of this. And you can see all the CPU flags. This is different features and things that the CPU is capable of. You can see we've got the VMX flag in here, which says CPU is capable of doing VM acceleration. Those are the main things of interest you'll probably get out of here for the time being. Get CPU clock speed you can find here as well. So yeah, that's how you check the CPU. If you're looking for RAM is the next thing. Obviously top is another one. If you press the greater than key on this one, it actually flicks columns across. For at the moment it's tracking based on CPU usage. It just so happens that the GNOME shell is also one of the higher RAM usage, so it's at the top. But if we flick to the right, you can see now it's reordered them. It's using the greater than key on the keyboard. It's now ranking them based on memory usage, and you can see that GNOME shell is actually, this is the login screen here, it's actually using a fair bit for what it's not doing at the moment in the background. And this is my interactive session that I'm logged into at the moment. You can see some of the other bits and pieces, things that are running in the background. Yeah, you can have a look through there. Evolution's an email client, so I'll have to see what to kill that. Didn't ask it to run that. You can see the firewall daemons running as well, doing things, and SSD is the it's like a authentication name server type system. Next thing to do is I often run the free command, free-m, and so this one here, it's basically the same information that you get out of the top command at the top there about the memory and swap. It's fairly similar. You can see that this one here has, this distinguishes between what's free versus what's available, and what's available consists of sort of some of the buffers and cache information that have space there as well. Once you've checked the memory and made sure the memory is not swapping, if it is starting to swap, then you just got to find a way to beef up the memory in the machine. If it's a VM, you just get permission to bump up the RAM. You can often do that hot now while the VM is still running. Otherwise, you have to, if it's a physical box, you have to find some actual physical slots to put in there, or you have to farm off some of the more RAM intensive applications to another host. Disk is the next thing you'll probably want to look at. So if we check the df command, this is usually the first one thing you run when you jump on a box and you're worried about something going wrong. This is df. You can see it's broken down to 1K blocks, but you're often better off -h. -h makes it human readable, so it's it actually converts it to meg or gig there. You can see that the root is taking up it's currently using 4.8, which, considering it's a graphical desktop system, it's not too bad, with just over half of it free out of the just below 10 gig of disk space there entirely. This is the boot partition. The only time that's likely to fill up is if you're you've had problems with installing the kernel and you need to reinstall some bits and pieces and reproduce the RAM disks. If you've got driver issues, usually only with physical hosts, most of the time that stays pretty low. The rest of these are various temporary file systems. They're not actually real file systems. They're taken up by, they're basically running out of memory doing various tasks and things. So they're not real disk. So those are the two there. One thing to note, this lists the amount of disk space, but there's if you haven't encountered it before, there's a thing called inodes. Inodes are basically the bits on a hard disk where it can contain file header information, and I have seen just fairly recently actually somebody managed to fill up all the inodes on a system. So you can find out that df-i. You can see that this one has hundreds of thousands of inodes free on each disk. Particularly on this one, you got quite a few there, but yeah, somebody did manage to something like, I don't know, tens of millions of files on a single host. So they had to clean it off a bit. They're mostly log files, I think. The next one we can we'll look at for disk space is the du command. So if I find out where I am, so I'm currently in the root's home directory. Du is actually, df is looking at the file system and saying how much space is free based on the whole file system. Du actually looks at individual folders and does things like, I usually do CSH, H is human readable, S is summary, and I'd have to check the man page to remember what C is. C is the total, and S is the subdirectories, I think. Summarize. Okay, so you summarize for each argument, and T is total at the end. So du-csh, and if we just go /bin, what this will do is go off and scan the bin directory, and bin's a symbolic link. So you can see it's pointing to user bin. So what we're better off doing is /user bin, and you can see it's actually gone through in that time and scanned all the files in user bin, and it's found that there's 253 mega files in there. The find command is another one. I'll go through a little bit more about it, but just to see how many files there are in that space, there's actually quite a few there under user bin. It's found all the files. Just a quick word count -l on that one, and there's 1500 files in there. So what we'll do is we'll have a look at some more directories. CSH on, say, etc. You'll see this is doing the C command, giving the summary at the end, or giving the tally. That's that one there, and the etc is doing correction. The S is doing the summary of each item. So there's only one item there. But if I do, for example, just a little bit of regular expression here. So this is basically if you find anything that starts with a letter between A and M, so it doesn't go all the way down to V there, and find the space on that. You can see it's got found bin, boot, etc. etc is the that's basically where it keeps system configuration files. Home is like where the user's home directories are. These ones are obviously empty, and all up it's found 369 out of those. If I take this out now and do the whole lot, usually, oh yeah, we got opt. That's interesting. That's where it usually puts third-party applications. Probably when you put Chrome there. That's probably where it put it. Oh, there, yeah. Google Chrome. Yep. Run, files related to the things that are currently running. User is that's where the binaries often go. So when a package gets installed, it might put bits all over the place. It might put the binaries in user, the libraries in various lib directories. These are clearly links to something else. Yeah, lib and lib64, so they're both under user as well. So all the libraries and binaries will happily be living together under /usr. And what else have we got here? Opt, we covered. Root, that is actually root's just root's home directory. It's often stored there instead of under /home, because /home is often mounted somewhere else, and if you have some sort of issue with mounting home, you want root to still be able to log in and do what it needs to do to be able to troubleshoot the issue. So root's always stored in /root. Var here, /var is where it puts the variable, like size, files that are likely to vary in size. So any sort of spool or cache files, any database files related to the running system, log files particularly go there. That's often spun off into its own file system as well. You might put it on a different disk, just because that's the file system that's most likely to fill up, and particularly if somebody's spamming something, doing something wrong, that's spamming the logs. So by putting that on a different file system, you won't necessarily halt the operating system if it runs out. It'd be mildly inconvenient, but the system can keep running. So that's what else we got from. Next thing is I'll just check the show file system. So as I said, under etc is where a lot of a lot of the system files and configuration files are kept. FS tab is file system table, and this shows what file systems are being mounted. So this one here is our root file system, and you can see it's XFS defaults. If you check the man page for FS tab, you can get a list of what defaults are. And these two numbers at the end, they're not used very much these days, but they're usually the first one is for what happens in a backup situation, whether or not this one should be backed up, and the second one is usually for if file system checks have to be done on boot, what order they're done in. So the main one, I should put boot as the main one, is what's getting checked and backed up. But you can modify that, and that doesn't happen by default. You've got to have some things that are actually going off and checking for that. But you can throw in extra, like if you've got an extra disk, you might throw it in here. If you've got you want to mount something off the network at boot time, you might put an entry in here for that. There's all sorts of things you can put in here. You can put Windows file shares, NFS file shares. You can put pretty much any SCSI device, any fiber channel, SCSI, any of that sort of thing. And related to this is the mount command. Mount is usually used for mounting a file system, but you can also have a look at different things that are installed. And so this is going a bit beyond just normal file systems that are mounted. If you have a look through, you'll find our root file system is in there. With these are the different. This is what this defaults here consists of. It's showing here all the different options that it's mounted with. Like read write is the main one. You'll often see things come up as RO if there's been some sort of disk issue and it's switched them to read only. You've got your boot there as well. And you'll find any others showing up in here if you're mounting other file systems from any other place. While I'm on file systems, I mentioned before about the find command. There's two commands usually used for finding files. There's /find, aggregation find. You might say /etc. This is the location where you should have a look, and you can have something with name hosts, and it's found two files that have hosts in the name. And you can have things like host star, and it'll find wildcards that match that, so anything starting with host and ending in anything else. And you can have things like, you can say iname for case insensitive, so there's no difference in this case, but for example if we had two files that had a very similar name, or if you had you're looking for anything at host and you don't care whether it's uppercase or lowercase, you do the iname. The other one's locate. So there's a package called mlocate, and it's got a couple of key programs. So the one is update DB. This is usually run as part of the cron process that runs daily. Cron is the system that sort of runs jobs regularly. So you might have things that run hourly or daily or monthly or however often you want them to run. You can set the update time on that. Usually update DB is run once a day or thereabouts, and then that feeds in. What that does is it indexes the file systems and makes it available to the locate command. This is usually local file systems only though. You can check the locate and update DB man pages to see exactly how it decides which file systems to index, but if you did then the same thing, locate hosts. This is not checking against the running file system, it's instead checking against its database, and it's usually a bit quicker. So this has found anything that's got hosts in the name, including, so you've got hosts in there, so it doesn't distinguish that, it doesn't make it the full name, but you might say things like /hosts. And you can see there's a few more, you can find them there, and you can pass it through like grep for etc. You can find that's basically what we did before. That's got, yeah, something that we didn't do that when we were using the find command. We just did the things that start in host, not one that ends in host like that. So the next thing you want to be looking for is usually if you've gone through CPU, RAM and disk, you probably want to look up network settings, and there's a few different ways you can do that. You can use the IP command. IP has a lot of different options in there. Address and route are probably two of the main ones you want to look up. Being that this is Linux, and Linux engineers and sysadmins tend to not want to waste keystrokes, you can actually just do the first letter of each one. So IPA will give you the IP address information for each of the interfaces. You can see that this particular host there's the loopback interface, which is, localhost 127.0.0.1 that every host pretty much has in the world. Then the next one here that we've got, this is the actual physical, or the simulated physical interface. So this is what would be a physical interface if it was a real box. And you can see here it's grabbed an IPv6 address as well as a IPv4 address. This is the one that's currently using for communicating. So it's grabbed .76 on that range. These virtual bridges are usually used for virtual machine networking and things like that if there's VM running on top of here. So we'll just ignore these ones. But for this one here, that if we do IPR now, or IP route, you can see that the default link is out 192.168.122.1. However, it has these other, if you go into that network, then it says to use this interface, and if you're going out that network, use that interface. So by saying default is this one here going out that interface, it'll go out there first. Usually the route command also does the same information but formats it a little bit differently. You can see what the default is. The default gateway is going out that interface, and then these other two subnets going out these other interfaces. Pretty much the same set there but different format. So once you've had a look at those, ifconfig is another command. This is a much older command. It predates IP by quite a lot, and you can also use that for configuring. You can use these commands to configure IP address information as well. However, it's not ideal because the IP system is now managed by a system called Network Manager. All of these, I'm going through these pretty quickly. This is mainly just to look up the information I'm telling you. I'll cover some of them more about how to configure this and later on further down the track. But you can always check the man pages for these and look up more information about the commands. The next one, NMCLI. So this is Network Manager CLI. This is the command line interface for Network Manager. That's what NMCLI stands for. And we can use that to have a look at the existing connections. So you can do connection show, and it shows a list of connections on the box. Or you can do they either do shortened versions of these, con show, or some people just to save some keystrokes, CS. And you can do con show, and you can specify these are connections. These are the devices that they attach to, but they often give them the same name. So this is, we'll just go get the NMCLI connection, show, and then this connection, and it shows all the information related to this connection. And you can see there's quite a lot there. Some useful information it gets out there. It shows what's come from DHCP. Actually, I'll go back up the top. This is connection information about what type it is, what interface it's going out, bit about the auto startup time and things like that. If we get down to the IPv4, we can see the method is auto. That means it's getting it from DHCP rather than assigning it itself. However, if you want, you can change that to manual, and you can set these just using an NMCLI command. I'll go through that once again later in other videos. That's how you check that. The next thing to check is running services. The system CTL command is what's used now. It used to be the chconfig on RHEL 6 and below, or Enterprise Linux 6 and below, CentOS 6 and below as well. But now on 7 and above, they use the system CTL command to check what's going on. You can check all running services by -A. You can see there's quite a few here. This is, you can see these are mount points, paths. This is so it's not just limited to services, but if you come down here to services, we can see like this at daemon is a good one for having a look at. This is for if you're planning for a job to run once somewhere in the future, you use the at daemon. So at daemon is currently loaded and it is active and it's running. So you could have loaded but inactive means that some of these things they don't need to be running all the time, so they could be loaded but they're inactive. So yeah, at daemon's loaded and it's active, and if we do system CTL status ATD, it'll tell us a little bit about it. So it says, when it started, if it's running, you can get some usually command line information out of there. And so we can stop and start it from here as well. You can see now loaded, but it's currently inactive. You can see it's enabled by default, but not currently running. It's dead since we just killed it 4 seconds ago, and we can tell it to start up again. So that's the basics of how you do sysadmin tasks on running services. Firewall D in there as well. If you want to drop the firewall, you can just stop that service. Better to manipulate the firewall rather than just drop it all up. That's another thing we can check. Firewall. That one also has a command line interface. There is a bit in here, and to go through and modify it if you want to make changes to the IP to firewall. This is part of the Firewall D system. Firewall D is actually just a wrapper around IP tables. I'll show you the zones, and I'll just run your list all zones. These are the default zones that are installed. I haven't modified these at all, but you can see the current active ones. You've got the public zone, and that's, you can see it's got the main interface attached to it, and these are the services that it allows. Cockpit's a system that you can use for a web interface for managing Linux hosts. It allows the DHCP client ports in and allows SSH in. SSH is a secure shell. Use it for getting command line access on remote boxes. These are some of the other ones that are set up. Trusted, you might, rather than throw an interface on there, you might throw individual IP addresses on there or something like that to say that host over there, I trust that, you can let that one in. Some of these others, these internal and home, they just have different lists of services that are allowed or not allowed. Then if you get up here, you can find you've got things like block and drop. And so these are, if somebody tries to connect on the block, it'll get a rejection come back to it. Whereas if you put an IP address or a interface on the drop, it'll just silently drop them and pretend it's not on the network or not listening. So that's, I'll show you, there's a bit of a IP tables. L is list out the rules. N, I think, is don't look up IP addresses for the, use IPs, not don't look up the DNS names, and V is verbose, so it actually includes information about number of packets included on each rule. But if we hit this, it's actually, it's not too bad. You can see there's a bunch of rules allowing certain ports in. What else have we got? System targets. So system CTL also controls targets. Targets are basically the new usage of what used to be called run levels, where you could actually have different states that the system can be at, and you can tell it to move back and forth between different states. So if we get default at the moment, you can see it's got graphical.target here. What that does is, if we go set, and you can just use tab complete to see what targets are available. This is all the list of targets that there are. Many of them are transitory, so you include them as prerequisites for other targets. And you can see there's a bunch of here to replicate the legacy run level targets, but the main ones that you'd actually use are there's graphical, which is currently set to as the default. That means that by default it starts up a graphical interface. You'll want there's multi-user as well as another one. That's your normal command line interface. Any command line host, any headless host, you'd normally set that as the default. And you might get those are the two main ones we really use. Things like reboot target and halt target, or what it does if it's it's shutting down or rebooting. But the rest of them, you normally need to worry about them too much. Next thing is local users. So in later videos I'll be going over authenticating of network sources, but for now we're going to have a look at local users. So the command for checking user information or checking against user and group databases and things is getEnt. So, and the password is the password database. They've actually removed the passwords out of there and put them into shadow because you don't want them to be. It's basically, they used to be able to be brute forced relatively easily back in the old days, and so you wanted to hide them away so people couldn't brute force other people's passwords. But if you get in password on this box, it'll getEnt. That's why getEnt. You can see this is listing everything that's all of the local users. So you can see my local user is there. You've got postfix as a mail system. There's a lot of services that run as an unprivileged user rather than as root, which is the better way to do it. You can see the root user is in there as well. Where this information is actually coming from is cat etc password. So you can see that's pretty much the same information. This X here is telling it that the password. If we go through the fields in this, so just look at my user here. Got J Alcock is the username, and that's the password field. The X tells it it's actually getting the password from the shadow file instead. There's or the shadow database. You've got the user ID. That's my default group ID. Comment with information about it. So in this case, host username. You got the home directory and the default shell. So this is it. When I log in, it actually gives me the bin bash shell command essentially. If we do the same thing, rather than password, we do group. This gives a list of all the groups on the system and any information about what users are in them. You usually get a group for the individual users set up, but on an enterprise system you might give everyone the same default group, and once again that's coming out of etc group. And I mentioned shadow. That is the password in an MD5. MD5. It's a MD5 hash anyway of the of my actual password, and it's salted with this. So it's actually adding this to the password before it's encrypted. So it basically makes it so you can't brute force it as easily. People used to produce what's called rainbow tables back in the old days, where they'd basically have these gigabytes and gigabytes of password lookups, where somebody's gone through and calculated all the hashes, and you could just compare that to this part of the MD5 sum, and it would give you back what the password is. But by adding a known salt to the password, it actually counters that, because it's no longer useful having that massive database, because you've got to have an individual database for every salt that is created, so it's kind of makes them useless. That's user information, and the next thing is, if we look at maybe date and time, the first thing you want to look at, sometimes when a service isn't working properly, it's because the date's wildly out. Just running the date command will do that. Date command has a whole lot of other options you can run. Date-i will give it a nice pretty date with no spaces, which we often use for creating new directories with a date in it if you're doing backups or backing up a file. Otherwise you can do date plus %s for, this is a good one for getting epoch time, number of seconds since the 1st of January 1970. That's the way Linux records its time internally, and that's usually recorded in Greenwich Mean Time or in UTC and then translated to local time. The last thing I was going to demonstrate is there's a command called Dmi Decode, and this is very useful because it spits out a whole lot of information about the physical details of the host. So if you go through, this is a virtual machine, so you don't get as much out of it, but you can see the actual BIOS vendor and details about when it was installed and when it was released and that sort of thing. You can say this here, it's got a manufacturer QEMU, that's the virtualization, but normally you'd have the vendor of the machine, so HP or Dell or something like that in there, and you can actually look up under chassis information. This is the case. It doesn't have that in here because it's virtual, doesn't have a real case, but you can also get things like motherboard information out of here as well, get the main board version numbers and things. Got some more processor information here about your CPU. There's 2 of those, and then we get into memory array, so talking about actual memory slots and things here. You've noticed that these have DMI types against them. Type 16 is that's the actual memory, or it's physical memory array that it says there, but it has the maximum capacity of your motherboard and things like that, and it's useful. And then it's got the actual individual memory slots. So being a virtual machine, it's saying you've got one slot that's capable of 2 gig and it's got a 2 gig slot in it. That's about it there. Sometimes you can find other information in there. Smart CTL you can use for getting information out of your hard disks as well, but because they're virtual, we're not going to get a lot out of them. You can get the information about whether they're failing and what state they're in, and you can get form factor information out of them as well. SmartD is usually pretty good like that. So yeah, that's some basic commands. So just go in and have a look at your box and see what it's doing, and if you want to find out what's broken, those are usually the places you check first. Journal CTL is another good spot as well. It's the log file. You can go through there and you can see what the system's been doing. It takes a bit of practice and time before you understand this and you can actually read it properly. But that feeds into log messages. This is the main place where it spits out information. Any running service or anything that's failing or having issues, it'll spit out some debug information there. Right, I think that'll just about do it for this video. So hopefully you found that useful. If you have any questions or comments or anything, leave them in the comment section, and I'll see if I can answer them in a video later on. Right. See ya.